Good evening to all. Today, I'm going to discuss the topic non-parametric tests. So, in a quantitative research, usually we use parametric and non-parametric tests. So, now question is, what is the theory behind the parametric and non-parametric tests? So, parametric test, before come to the parametric test, I would like to discuss about the primary level of measurement. Actually, which statistical tool we use in our data set, it depends on the measurement level of scale. So, there are four types. One is nominal scale questions. So, nominal scale, the questions you can prepare like this. What is your gender? Basically, nominal means categorical, mutually exclusive. So there are two options, or the option A, male participants, and second is female. Is it clear?
रोटी खानी है पर आज हेलो
Okay. The question of the nominal scale you can prepare mutually exclusive, or the another question may be, what is your education? What is your education background? Okay, so you may belong to science, commerce, and arts. So in nominal scale, the options may be two or more than two. In this case, if we have this type of question in our survey or research thesis or paper, then we can compute only the percentage or frequency. We can present our data in a percentage form or frequency, like the how many participants belong to the UP and outside UP. So out of the 100 participants, 30 may be outside UP, outside, and 70 respondent belong to UP. So we can present this data either actual number 30 and 70 or in percentage. The second type questions we can prepare, that is the ordinal scale. Ordinal scale, basically ranking, or you can develop your question in Likert scale. There are 5 or 7 points: 1, 2, 3, 4, and 5. 1 means strongly disagree, neutral, and strongly agree, and strongly agree. You can create 7-point or 9-point scale also. Third type of questions we can prepare, that is interval scale. In our research paper or thesis, interval scale. Interval scale means you can create category 1 to 9 or 11, poor to excellent. Okay, and these are the options 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Last question we can prepare ratio scale, ratio scale. Ratio scale means example of ratio scale: age, income, profit, etc. So you can prepare your question like, what is your age? What is your age? So age start from 0. So your age may be 4 years, 5 years, 10 years, 20 years, 30 years, 40, 50, 60, 70, 80. Okay. So in case of the independent t-test, if I want to apply independent t-test in my data set, then I need two questions. The one question should be the continuous question. Continuous means, what is your salary? So we can express salary in terms of rupees. And second, what is your gender? So we can compare salary of male and female. But when we apply independent t-test, before independent t-test, we check the assumptions. Means data should be normally distributed, data should be homogeneous. In case my data not normal but homogeneous, my data normal but not homogeneous, in both the conditions I cannot apply independent t-test. So what is the condition? The data should be normally distributed and as well as homogeneous, then I can apply independent t-test. If my data not normally distributed, not homogeneous, then what should I do? Am I wrong? No, you are not wrong. If your data not normally distributed, then equivalent of the independent t-test, we can apply Mann-Whitney U test. Mann-Whitney U test equivalent of the independent t-test. So today we will discuss the Mann-Whitney U test and the non-parametric tests. Basically, non-parametric tests are assumptions free test or distribution free test. We do not need to check the homogeneity and normality of the data. So in a non-parametric test, what happens? Our continuous data automatically convert in a ordinal form. Ordinal, because it is non-parametric data. So if my data in a ratio scale, so when I apply Mann-Whitney U test in a SPSS, so SPSS computer software convert ratio data in a ordinal. What does it mean? For example, I am asking the salary of 5%. The first person salary 45,400, 60,000, 32,000, 40,000, and 50,000. So it will convert, the software will convert this ratio data into ordinal. Ordinal means rank order. So I'm giving rank 1, the whose salary is high. The rank 1, then rank 2, rank 3, rank 4, and rank 5. Is it clear? So the Mann-Whitney U test, basically in a Mann-Whitney U test, we can compare two medians. Instead of the mean, here we will use mean rank, basically. The third technique, that is paired t-test. In a equivalent of the paired t-test, equivalent of the paired t-test, that is Wilcoxon rank sign test. In a paired t-test we apply, there are two conditions. One is before treatment and another is, this is manipulation or experimentation. Before and after. If my data not normally distributed, then I will use Wilcoxon rank sign test, which is equivalent to the paired t-test. The third test, yesterday we discussed ANOVA, analysis of variance, one-way ANOVA. Equivalent in a one-way ANOVA, basically we compare more than two means. There are three categories: low, medium, and high. If my data not normal, not homogeneous, equivalent of the ANOVA, I will use Kruskal-Wallis test. Is it clear? And the fourth test, repeated measures ANOVA. In case the assumptions of the repeated measures ANOVA do not fulfill, then we use the Friedman ANOVA. So today I will discuss the 5 tests. The first is, and we should keep in mind the one thing, the measurement of a scaling. There are 3 main types of the quantitative technique. One is univariate technique. In a univariate technique, if my data set dependent variable metric form, then I will use one sample t-test. But if my dv dependent variable in ordinal form, means non-metric, then I will apply one sample median test. Second is the second technique, that is bivariate technique. Bivariate technique. In a bivariate technique, there are 4 categories. In this matrix, you can see the dependent variable metric. When I talk about the metric, it means I am talking about interval or ratio type questions. Non-metric means the questions nominal and ordinal. Then metric, non-metric, and here independent variable. If my both the questions y and x, y means dependent variable and x means independent variable, if both the questions in metric form, then I will use simple regression analysis. Is it clear? So for the simple regression analysis, we require both the variables should be metric form. If one question metric and another non-metric, then we cannot apply the simple regression analysis. Same as if my both the questions, this is first condition. Second condition, if my dependent variable metric and independent variable non-metric, means 2 categories, then I will use the independent independent t-test. Independent t-test. If category more than 2, then I will apply ANOVA. Same as if my dependent variable and independent variable, my DV and IV, both are non-metric, means categorical, non-categorical. Then this is dependent variable also non-metric and independent variable also. Then I can use, or I will use only chi-square test. So the questions may be like this: yes, no. Another variable, male, female. I am asking to my respondent that do you like coffee? So there are two options, yes and no. And the same questions I am asking from the male participant and as well as the female participant. In this case, when both the dependent and independent variable in a categorical form, then I can use chi-square test. If my data are set, the dependent variable non-metric and independent variable metric form, then I will use discriminant analysis. So when we are preparing our questions, we should keep in mind that if I want to apply the multiple regression analysis, so what type of question should I prepare to apply multiple regression analysis? Multiple regression analysis. Multiple regression analysis means one dependent variable and several independent variable. So, but the condition is dependent variable. Why? Should be in a metric form. My question should be either interval or ratio, and the other questions, independent variables, should be metric. All questions should be metric. For example, the sales of the company. So sales, we measure sales in terms of the rupee, or weight of the person. Again, we measure in terms of kg, continuous scale. So to measure the sale, I'm taking two independent variables. One is sales depend on advertising expenses and discount. Both are metric data. So I can predict how much advertising expenditure or discount we give to the particular or desired sales. So when we prepare the questionnaire, we should keep in mind, if I want to apply the particular test, is it possible me to apply that particular statistical tool or technique? Sometimes what happen, many students prepared questions in nominal scale and they want, okay, sir, we want to apply ANOVA, correlation, regression. So we cannot apply because the nature of the questions not desirable to the particular test. So before preparing questionnaire, we should keep in mind when we apply the particular statistical tool or technique, whether these questions appropriate for that technique or not. Is it clear? So non-parametric test, basically, these tests are the assumptions free test, do not rely on the data belong to any particular parametric family of probability distribution. It means these tests are distribution free test. Non-parametric tests are used when assumptions of the parametric test are not met. Means data not normally distributed, data not homogeneous. So these are the tests. Today I will take each test case study and apply the SPSS software. One is Wilcox-Cohen rank sign test. For one sample, I can use either median test or Wilcox-Cohen rank sign test. For two independent means we have divided category into two groups. So two independent sample, male, female, rural, urban. The second is if I want to compare two categories, then I will use Mann-Whitney U test. Third test, two dependent sample, two dependent or two related sample or paired sample. ठीक है, टर्मिनोलॉजी सेम है, तीनों का मतलब एक ही है. So if we have two dependent sample like paired sample, then and assumptions of the paired or dependent samples do not fulfill, then we will apply Wilcox-Cohen rank sign test. Third test, that is Kruskal-Wallis test, when we have more than two categories, more than two levels, more than two independent samples, then we will use Kruskal-Wallis test. And last is Friedman-ANOVA. So more than two dependent sample. If I want to apply the discriminant analysis, so we should think what type of question should I prepare for applying the discriminant analysis. So the purpose of discriminant analysis to classify objects into two or more groups. So one dependent variable should be categorical and several independent variables should be metric. Okay. Now the first test is one sample Wilcox-Cohen rank sign test. One sample Wilcox-Cohen rank sign test. The one sample sign test simply computes a significance test of a hypothesized median value for a single data set. Here I am not using the mean value. I am using the term median value for a single data set. The one sample sign test is non-parametric hypothesis test used to determine whether statistical significant difference exists between the median of non-normally distributed continuous data set and standard. What should be the condition for the one sample Wilcox-Cohen rank sign test? The data should be ordinal or continuous scale and observations should be independent. The example of the one sample Wilcox-Cohen rank sign test is this. In this example, the company X tires launched a brand new tires for brand brand of tires for cars and claims that under normal circumstances the average life of tire is 40,000 kilometers. It means tire will run 40,000 kilometers. A retailer wants to test these claims and has taken a random sample of 10 tires. He tests the life of tires under normal circumstances. The results obtained are presented in the table. The first tire life was 36,000. Second tire life was 37,000. Third tire life 41,000 and so on. So first of all, we will develop the hypothesis whether the retailer claim right or wrong. So here the population mean, in the population mean means 40,000. I think he the company was claiming that the 40,000 kilometer, the tire will run the 40,000 kilometers. So in a null hypothesis, we always assume there is no difference between population median and sample median. Both are same. But alternate hypothesis says no, population median does not equal to the sample median. It means if population mean does not equal to sample mean, what is the population mean? 40,000. If 40,000, if the average life of the tires near to 40,000, we can say the company is claiming right. The company not manipulating anything. Company is speaking truth. But if it is not equal, like 30,000, so there is a big difference. So we can say company not telling the correct things. So in a null hypothesis, basically we assume the population median does not equal to the sample median. Is it clear? Now I'm taking the case study or data set.
Sir, can I ask a question here?
Yes, sure.
Sir, why shouldn't we use the mean here? Because only we are considering median, but not the mean. So we are only dealing with the median right here.
Yes.
Yeah.
Uh, the data, actually, I told you uh, in a non-parametric test, if my data in a continuous, if my data is continuous, means ratio scale data. So the software will convert continuous data into the ordinal data. And in a non-parametric test, we use ordinal data. Is it clear? So in a, for example, in this case, so first of all, this data, you can see all the data in a ratio scale, continuous data, but data not normally distributed. So this data will convert into ordinal, and in a ordinal, there are three things: mean, median, mode. So in a mean, we cannot take, there are in a central tendency, there are three terms: mean, median,
Median
and mode. So mode basically tell us about the frequency,
frequency, yes.
and median tell us about the 50% observations below this point and 50% observation above this point. And mean give the average. Average means we are combining all the observations and then dividing the number of observations, so we will get the mean value. For example, gender is categorical variable, so we cannot take the mean value of this data, because gender, it is nominal scale questions. So we can present it either the frequency or percentage, male and female, but we cannot take mean value of gender. So same as in a ordinal value, ordinal data, we cannot take the mean. Yes, we can take mean rank. Mean rank we can take, but we cannot take the mean value of the data set. And for more detail, I am showing you the one book. The book is now you can see the chapter. Compare 2 means comparing, 3 means analysis of variance, factorial ANOVA. Yes, non-parametric test. You can see here the non-parametric test, page number 539. Now you can see here the non-parametric test 539. Yes, non-parametric test. Okay. When to use the non-parametric test? इसमें बताया कि when the assumptions, so in a non-parametric test, basically data ranking of the data. Is it clear? So here we are using ordinal data, ranking the data. So in a non-parametric test, the data set convert into the continuous data convert into ranking data. So here the I'm giving the example. इसको कैसे rotate करें? Rotate. देखिए in this data set you can see these are the scores. इसको rotate के लिए अभी actual bit you can see the data set here, the score 3, 5, 6, 6, 7, 8, 9, 10. Basically these are scores. So here the lowest score rank, potential rank of this score is 1, and the next lowest score rank is 2. So here we will take the mean rank instead of the mean value. So we will use the mean, and this is the criteria to this is formula of the independent Mann-Whitney U test. You can go through this formula. U equal to N1 into N2 plus capital N into N1 plus 1. So for more detail, you can go through this book.
Okay, sir.
Now this is my data set. So the data is continuous, although there is no need to check the normality of the data, but data is continuous. So I will check the normality, whether my data normally distributed or not. So first of all, we will check the normality, analyze, descriptive statistics, and explore the life of tire. I'm transferring here dependent list, then plots, normality plots with test, and then continue. After continue, okay, now I can show you the results. So here you can see the result. The p value of the case test, which is less than 0.05. The p value it is 0.047, which is less than 0.05. So data not normal. The data not normal. If my data not normal, after estimating the normality and homogeneity test, then I will go for non-parametric test. Now I can apply the non-parametric test. So in a non-parametric tests, how to apply the non-parametric test? So the go to analyze. There are two things One is through the one sample we can test, or through legacy dialog we can check the one sample KS test, or two independent sample K independent sample. K means Kruskal Wallis test, K independent sample. So I am applying the one sample Wilcox-Cohen rank sign test, analyze non-parametric test, and one sample. Here test sequence of randomness, tick this button, then press this button, field. So the number of tires we do not need, it is just a serial number. We need these values, life of tires. So we have transferred, by default it is transferred in the test field. Then setting, go to setting. In a setting, then custom test, compare, tick this button, compare median to hypothesize Wilcox-Cohen signed rank test. And we should write the value here. So the company is claiming tire will run 40,000 kilometers. So I am writing here 40,000. And then run. After the run, we can see the table. Here the one sample Wilcox-Cohen rank sign test. What is the value? P value here 0.574, means it is greater than 0.05. It is non-significant. So the difference is not significant. So here the P value greater than 0.05. So we will interpret that the difference, the median value, observed median value is 41,000 kilometers. 41,000. So there is no significant difference. You can see the hypothesized median was 40,000 and the observed median, that is 41,000. So there is a difference of 1,000. Whether this 1,000 difference significant or not. So here asymptotically significant two-tailed test will tell us. And here P value, now here P value greater than 0.05. Greater than 0.05. It means this difference is not significant. Now question is how to interpret this result in our research paper or thesis. So the null hypothesis was the population median is equal to sample median. So here you can see the Wilcox-Cohen sign rank test indicated that median life of tire 41,000 was not significant higher the population median. Okay. The second test, that is Mann-Whitney U test. Mann-Whitney U test. Mann-Whitney U test basically equivalent of the parametric test, independent t test. The Mann-Whitney U test is non-parametric test that can be used in place of an unpaired t test. Basically, there are three names. We can say unrelated sample, unpaired t test means independent t test, or another name is unrelated t test or unpaired t test. And there are three names we use for a paired t test: paired t test, and dependent t test, and related t-test. Mean is same. Okay. So the Mann-Whitney U-test is non-parametric test that can be used in place of unpaired, means equivalent to the independent t-test. It is used to test the null hypothesis that two samples come from same population, have same median, or alternatively whether observation in one sample tends to larger observations in another data set. Now the case study of this and the condition is the one variable should be two labels, means independent variable. There are two types of variable in a Mann-Whitney U test. The one variable, that is the independent variable, should be categorical like rural, urban, and another dependent variable should be either ordinal or continuous. If my data in a continuous, then software will automatically convert into rank in a ordinal data. Okay, this is the prerequisite of the uh, two independent samples. Mann-Whitney, we should prepare if we want to apply the non-parametric test Mann-Whitney, then one question should be dependent variable should be either ordinal or continuous data, and independent variable in a nominal data. Like you can see here, there is data set, depression score, that is the dependent variable, and there are two categories. The doctor is giving a ecstasy tablet to the patient, and another group is giving syrup, and doctor wants to know whether uh, syrup more effective than tablet or not. Okay, so there are two category. The null hypothesis. So I will आपको एक केस स्टडी पहले इसका बता देता हूं. I am opening the case study of this data set. Independent sample t-tests. Another case study, paired the independent, sorry. One is the Mann-Whitney U test. Another case study. I'm opening some case studies. I will show you. Then second case, Wilcoxon rank sign test. Third case study, Kruskal-Wallis test. And fourth is Friedman NO. Now you can see the case study. I'm showing you case study. Case study. Is it visible? Can you see the case study? Back depression in
Yes, sir. It's visible.
Okay. In this case study, a neurologist might collect data to investigate the depressant effects of certain recreational drugs. She tested 20 clubbers in all. 10 were given an ecstasy tablet to take on a Saturday night, and 10 were allowed to drink only syrup. So there are two groups of 10 each one group the doctor is giving a ecstasy tablet and another group she is giving syrup at the Saturday night. Then level of depression were measured using the back depression inventory. There is a questions set of questionnaire. So the depression score of the first participants who consumed tablet, the depression score was 35, 28. Second participant 35, 35, 24. And the another group, the those who are taking syrup, the first participants depression score 5, 6, 30, 8, 9, and so on. So here we want to know whether the ecstasy tablet effective for reducing the depression level or serum. Is it clear? So I have collected the data set of 20 participants, and these are the participants score. The participants, the ecstasy tablet users, and another group, this all the 10 people are taking serum. So I want to compare whether depression level will be less in ecstasy tablet or serum. So I will use Mann-Whitney U test. So here I am comparing the mean rank. Is it clear? So software will automatically convert this data into in a rank. So rank, what is the criteria of rank? In a ranking, generally in a rank we give the rank 1 those who obtain the highest score, but here we are ranking those who are getting low score. So here we will give the rank number 1 because the depression score is less, and then second rank to the 5 number. So before giving the ranking we should create the data in a descending or ascending order. So I have shared you the data set of this. You can see. Yes. So it is not possible you to in a score. These are the score of 20 respondent. You can see here the score 3, 5, 6, 7, 8, 9, 10 ascending order, and the highest score was 35, 39. Is it clear? 39. 39 was the highest score. So we are giving here rank 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So rank, we are giving rank. So although we do not need to give rank, for understanding purpose, I am showing you this table. SPSS software directly calculate the median value. So go to analyze, then non-parametric test, independent samples, analyze, non-parametric tests, independent samples, then compare median. Here you can see the term not mean, here term is median for ordinal data. Compare median across group. So there are two groups. Then press this button, fields. Transfer types of drug into groups. There are two groups, ecstasy tablet and syrup, and continuous data transfer into test bit. Is it clear? Now we will press this button setting and then customize test. You can see there are many tests. but we will tick only Mann-Whitney U test. I already told you Mann-Whitney U test compare the two medians. Is it clear? And then run. After tick the Mann-Whitney U test, run. Run, then we will get the output. So the output is independent samples Mann-Whitney U test and p value is 0.001. The point, so p value less than 0.05, it means there is a significant difference. But we do not know whether the tablet is reducing the mean weight, the depression level or the syrup. We don't know. So here you can see the detail of the output. So total, here you can see the mean rank of the green means the mean rank green means syrup, those who are taking syrup, and blue means ecstasy tablet. Syrup and ecstasy tablet. You can see above this diagram, ecstasy tablet. So what is the difference? The mean rank of the syrup was 15.15. There are two groups. One, syrup. Those who are taking syrup, what is the mean rank? 15.10. And the tablet mean rank is 5.90. Whether this difference is significant or not, who will tell us? P value. So P value we will obtain from this table. P value should be less than 0.05 for significant difference. And here asymptotically P value 0.00 means less than 0.05. It means this difference is significant difference. So this, then we will write the results, reporting the results. Ecstasy tablet users were significantly more depressed than the drink syrup users. So here the test in this lecture work on the principle of ranking the data for each group. Lowest score a rank of 1, next highest score of 2, and so on. Then tied rank are given the same rank, and then average, we take the average rank, add up ranks for the two groups and take the lowest of these sum to our test statistics. This analysis is carried out on the rank rather than actual data. Yes, you can see the ranking of the data. So first of all, we will create our data in a ascending or descending order. So there are 20 observations. The 1, 2, 3, total 20 observations. Out of the 20, 10 are ecstasy users, ecstasy tablet users, and 10 syrup users. So these lowest score treated as rank 1. So in the rank, sum of rank of syrup, alcohol, what is the rank? A means syrup user and E means ecstasy tablet user. So we will take the rank 59 and 159. Same as the rank 90, the sum of ranks 90 and sum of rank of other group is 119. So this is the criteria to taking the rank. For more detail, you can go through the book. Next case study, the Wilcoxon signed rank test, which is equivalent to the pair t-test. If my data not normally distributed, then I will go for Wilcoxon signed rank test. These tests are not doing anything new things, but they are substitute of the parametric test. If you are using this test, the power of test is equal. Nothing wrong. कोई इसमें problem नहीं है कि हम non parametric data normal distributed नहीं है तो, because it is not on our hand. Now Wilcoxon rank sign test, there are two observations and respondents are same: before measure, before treatment, and after treatment. So pre-measure, before treatment, we will take the observations, and after the treatment or experiment or manipulation, we will, or intervention, we will take the post measures. The uses of the Wilcoxon sign rank test to compare two sets of scores when these scores come from the same participants. Imagine the experimenter in the previous example was interested in the change in depression level for each of the two drugs. We still have to use a non-parametric test because the distribution of a score of drugs were not normal. So this case study related to the stress, a neurologist investigated that the stress effect of certain drink. One, drink syrup, and another, the another group, she is giving syrup. So in this case study, the neurologist is giving syrup to the participants. There are 10 participants, 1, 2, 3. Drink syrup on a Sunday and then measure the score next day. Then after 3 days, she is giving the second time the syrup. So the 3 days period, it is basically time period or intervention. So before treatment, we will observe the data, and after the 3 days or intervention, we will. So here we are taking observation 2 times, before treatment and after treatment. So the hypothesis of this test is drink syrup. You can see the when in Sunday we are taking the observations, this the score of the one participant 16, 15, 20, and so on. After 3 days continuously, when the doctor is giving syrup to patients, then after 3 days she found the depression was lower. 16, earlier it was 16, now 15, 5, then 6. इनका बढ़ गया है डिप्रेशन अगर आप देखें 20 to 30, but rest of the participant score lower than the previous. Is it clear? So we will develop the hypothesis. The null hypothesis, there is no significant impact of syrup on reducing stress. We always assume that there is no impact of, or there is no relationship between the two. But alternate hypothesis says there is a significant impact of syrup on reducing stress. So we will check whether the difference is significant or not. If difference is significant, it means the p-value less than 0.05. If p-value greater than 0.05, it means there is not a significant difference. When we compare the two groups, always we will get the different value. But whether that difference significant or not, p-value will tell us. So I am opening the data set to performing the Wilcoxon rank sign test. So there are two groups. You can see the data set. So data at Sunday night, the depression score was 16. And after giving those 3 nights, Sunday, Monday, Tuesday, and the Wednesday morning, the score was less. So this is my data set. How to perform Will-Coxon rank sign test for non-parametric data. Go to analyze, non-parametric. So should I take related sample or independent sample? Anyone who would like to tell? Which one should I take? Independent sample or related?
Related sample, sir.
Related sample. Why?
The participants are the same. That's why.
Yes. You are right. Absolutely. Participants are same. That is why we are using related samples. Then tick this button, customize analysis. Next, press this button, fields. Transfer both the variables, back depression inventory Sunday and another day of observations. Then setting, press this button, setting, and customize test. Customize test. So here I will tick compare median difference. Here you can see compare median. So I am ticking Will-Coxon match pair signed rank or 2 and then run. After running, this is my output and the p value is 0.045. There is a significant difference. If you take medicine continuously, then your stress score is low. And then I'm showing you the another table. These are the score because p value is 0.0 less than 0.05. And same technique, I can use another method, that is analyze non-parametric test and 2 related samples. So I can analyze through this way also. Analyze non-parametric tests, legacy dialogues, 2 related samples, and then transfer both the variables BDI Sunday and BDI Wednesday. By default, you can see Will-Coxon is tick. We do not need to tick this option and then OK. After OK, you can see the output. The mean rank is 5.22 and the mean rank of the another group 8. And what is the p value? It is less than 0.05. Now we will write reporting the results. For drink syrup users, the depression levels were significantly lower on Wednesday than on Sunday. So इस तरीके से we can report our result. So how to report the result? In this book you can see it is very beautiful book for reporting purpose. So I am showing you the.
Sir, kindly allow to write the result in the previous slide. Please hold it for a minute. Of course, we will get the recording, but still.
Yes, no problem. You will get this. So here there are two groups, the one median that is 7.5 and another group median that is 16. And I'm showing you the actual analysis.
Okay, sir. We can go ahead.
I will share this. And then you can for more detail, I am showing you the हेलो हाँ देखिए सर ये जो रिजल्ट्स हैं now you can see the non-parametric test. Now you can see sir this result output. This is my result. ये देखिए writing the results. So how to write the results? You can write this way. For ecstasy user, depression level were significantly higher on Wednesday than on Sunday. तो ये जो डेटा आप यू कैन राइट इस तरीके से रिपोर्टिंग कर सकते हैं हर एक टेस्ट का राइटिंग द रिजल्ट कि हाउ टू राइट द रिजल्ट्स. सो इस बुक के थ्रू हम जो है डिटेल में और भी जो टेस्ट्स हैं उनके बारे में पढ़ सकते हैं. द सेकंड इज द नेक्स्ट स्टडी क्रॉस्कल वैलिस टेस्ट. हेलो
Yes, sir. This is okay, sir.
the क्रॉस्कल वैलिस टेस्ट which is equivalent to the analysis of variance. Kruskal Wallis test is non-parametric tests counterpart of the one-way independent ANOVA. If your data, you have data that have violated the assumptions, that then this test can be useful way around the problem. The theory of Kruskal-Wallis test is very similar to the Mann-Whitney-U test. In a Mann-Whitney-U test, we compare two median, but in a Kruskal-Wallis test, we compare more than two median. Yes. So in this case, so I'm showing you the case study. In this case study, scientists had discovered that the coffee consumption linked to higher heart rate. Means you consume more coffee, heart rate will increase. Researcher took 40 participants and split them into 4 groups that varied in number of caffeine consumption. The first group was a control group and had no coffee at all per day. None in the whole month. It's a 1 month experiment. The second group had 1 cup coffee per day, and after 1 month, we measured the heart rate score. The third group, 2 cup coffee per day, and the final group and had 4 cup coffee per day. At the end of the month, all of the participants were measured heart rate score. So here there are 4 groups. One is control group. We are not giving any coffee. And the another group, there are 40 participants in this study. So in the first group, we are not giving coffee. And after 1 month, and there are 10 participants, 1, 2, 3, 4, 10. The heart rate, and we measured heart rate score at the end of month. The heart rate score of the person 182, 78, and so on. The second group, there are 10 participants, 1, 2, 10, and we are giving 1 cup coffee per day to this group. And after 1 month, we are measuring the heart rate score. And the third group, we are giving 2 cup coffee per day throughout the month, and then we are measuring the heart rate score at the end of month. And the another group, we are giving 4 cup coffee per day. So here we want to know whether the dose of the coffee, 1 cup, 2 cup, and 4 cup significantly increase the heart rate score or not. So there are 4 groups, and in one group we are not giving any cup of coffee throughout the month. Second group, we are giving 1 cup coffee. So here basically we are compare means, rank. We will compare the mean rank of the 40 respondents, 4 groups. So the one where, and after 1 month, we will measure the heart rate score of all 40 participants. So this is my case study. So how will we develop the hypothesis for non-parametric test Kruskal values? The hypothesis would be the median outcome is the same across all categories. So there is no difference whether you consume 1 cup coffee, 2 cup coffee, or 4 cup coffee, your heart rate will not increase. The second alternative hypothesis says no, at least one pair of median different from each other. So this is very simple case study. Now I am performing the case study. So this is my case study. You can see here. So in this case study, there are 4 groups. The total respondents 40. You can count the 14, the data set of 14. And here we are giving no cup coffee to this group. कोई coffee नहीं दे रहे हैं, and we are measuring. Basically, it is control group. So we are giving 1 cup coffee. Sorry, no cup coffee. And after 1 month, we measure the heart rate score. Another group, we are giving 1 cup coffee, and we measured the we will measure the heart rate score after the 1 month, and these are the scores. Okay. This is my data, very simple data. So I want to apply Kruskal Wellness test because it is equivalent to the independent t-test. Independent t-tests. So my data set, there is my data set. 1 cup coffee. Yes. नहीं, ये नहीं. My file, opening data set, coffee. Yes. Now you can see the data set. So I am applying the Kruskal-Wallis test because we are comparing more than two groups. So go to analyze, non-parametric test, so and independent samples. Analyze, non-parametric tests and independent samples. Although I can perform through legacy dialogues, but the limitation of this option, we cannot get the post hoc analysis. We will obtain only results. So I'm applying non-parametric test independent samples. Then tick this button, compare median across group, tick this button, and then fields. So coffee consumption, it is categorical variable, transfer into groups, and heart rate score, continuous variable, transfer into test field. We have two options. The one option, I'm transferring coffee consumption, and another heart rate score. Then press this button, settings. So there are many tests available, but we will tick only Kruskal-Wallis test because I cannot tick this Mann-Whitney U test because limitation of Mann-Whitney U test, we can compare only the two samples. But here sample more than four samples and multiple comparison. So basically we will compare three pairs. The one no cup coffee with 1 cup coffee, one pair. No cup coffee with 2 cup coffee, another pair. And the third pair, no cup coffee with 4 cup coffee. And then we will check the significant difference in each pair. Is it clear? So then run, and after run, the score independent Kruskal-Wallis test. What is the p-value? 0.006, which is less than 0.05. And p-value, asymptotically p-value asymptotically p-value 0.006, which is less than 0.05. Now you can copy and paste in your result if you want. When the no cup coffee, the median value, the heart rate score value is, it is not visible here. So you can take the pairwise comparison. Here written independent sample t-test. You can tick this option, pairwise comparison. So we will get many pairs, but we desire only three pairs. Pairwise comparison. Now you can see these are the values. 2 cup coffee, 14.64 median value. 3 cup coffee for 31.35. 1 cup coffee, 19.65. No cup coffee, 16.35. So I told you we will compare only three pairs in our data set. There are four categories. Y equal to X. No cup coffee. कोई coffee नहीं. One group. 1 cup coffee, 2 cup coffee, and 4 cup coffee. So I am comparing this pair, whether the difference no cup coffee and 1 cup coffee is significant or not. So I am choosing this option, no cup coffee and 1 cup coffee. No cup coffee and 1 cup coffee. What is the p-value? P-value greater than 0.05, which is greater than 0.05. It means you can consume 1 cup coffee per day. There is no significant increase in heart rate score. Although I do not know whether it is actual or not, it is hypothetical case study. The second case study, the second pair is no cup coffee with 2 cup coffee. Second pair. No cup coffee with no cup coffee with 2 cup coffee. Yes, 2 cup coffee with no cup coffee. If you consume 2 cup coffee, the value of the heart rate score significantly different from no cup coffee. No. P value again greater than 0.05. So there is no significant difference. Last pair, no cup coffee with 4 cup coffee. No cup coffee with 4 cup coffee. What is the difference? Whether difference significant or not? Yes. Because P value less than 0.05, it means we should not consume more coffee, otherwise heart rate score will increase. Now you can write the results. You can report results PPT. Yes. एक the result. The result PPT कहाँ गई? ये आ गया आपका PPT. So first of all, we will develop the hypothesis. The median outcome is the same across all category, and another is at least one pair of median different from each other. So the heart rate scores were significantly affected by the coffee consumption. That is, the chi-square test value is for 12.45 and p value less than 0.05. So you can get this result from here also. You can, yes, sorry. You can apply another method also. Go to analyze, non-parametric tests and legacy dialogues and k independent sample, more than 2 samples. So here we will use k independent samples, and then coffee consumption transfer into grouping variable, how many categories for minimum is 1 and maximum is 4, and then continue. So there is another way to calculate the Mann-Whitney U test or Kruskal-Wallis test or Wilcox-Conn rank sign test. Through legacy dialog you can do it, and then exact, nothing to do here. Options, you can take descriptive statistics and as well as quartile, then continue. By default Kruskal-Wallis test, we do not need to tick this option, and then okay, and after okay, the results. Non-parametric, you can see the results. So no cup coffee, the mean rank 16.35, 1 cup coffee 19.65, 2 cup coffee 14.65, and 4 cup coffee 31.35. So this is our chi-square test value 12.45 and p value 0.006. It means there is a significant difference. So through post hoc analysis, we can compare the 1 cup coffee and 2 cup coffee do not significantly increase the heart rate score. But if we consume more than 2 cup coffee, then the heart rate score significantly increase. So we should not consume more coffee. So this is about the Wilcox-Conn rank sign test. Next test, that is the next test, Friedman ANOVA. Friedman ANOVA. So I am using the next test, Friedman ANOVA. You can report this result. The next is Friedman ANOVA. The Friedman ANOVA same as repeated measures ANOVA. In a repeated measures ANOVA, basically we take same respondent observations more than 2 times. It is used for testing differences between conditions when there are more than 2 conditions and the same participants have been used in all conditions. Each case contributes several scores to the data. If you have violated some assumptions of parametric test, then this test can be useful way around the problem. And this is case study, very simple case study. The total 10 women, these women wants to reduce their weight to test the efficacy of my wonderful new diet plan. The researcher took 10 women who considered themselves to be in need of losing weight and put them on this diet for 2 months. So first of all, we will take observations baseline 1, 2, 3, 10 women, baseline weight, then after 1 month, and then after 2 months. So we are measuring more than 2 times. There are 3 times we are measuring same respondent. So we will apply Friedman ANOVA. So the hypothesis is there is no significant impact of diet plan on weight loss. But the alternate hypothesis says there is a significant impact of diet on weight loss. This is my result. So I am applying the Friedman ANOVA one sample Friedman, yes. Now these are the score. Baseline weight 63.75. After diet plan, after 1 month, the weight instead of decreasing, weight is increasing, and after 2 months 81. The second participant score 62, then after 1 month increased 66.24, and last month 69.31. But another respondent's score you can see 107.27, and after 1 month 102 kg, and after 2 months 91 kg. So reducing, and another participant score reducing, but more or less through data we can say this diet plan not working, because the data, baseline data different from the final data. तो ये आप जो data set देख रहे हैं, this, so through this data I can say this difference is not significant. Yes, if 63.75 kg weight at the time of joining the program, if still weight is 63.75, then it is okay, but it is increasing. So I think this diet plan is not working for reducing the weight. So how to check it? Go to analyze. So I can apply non-parametric test, legacy, dialogues, and the K related samples, more than 2 samples. So it is K related samples. K related sample means more than 2 samples. Up, you can press this button and then select all the 3 data set and transfer into the test variables. We do not need to tick because by default it is Friedman ANOVA. And statistics, you can tick descriptive statistics and quartile, and then continue. After continue, okay. So you can see the output. The output, the mean weight of 10 participants were 78.053, and after 1 month 77, and after 2 months 70. So this difference is not significant. Now you can convert into these score into ranks. So 1.90 rank, 2 rank, and 2, 3. And what is the p-value? P-value is 0.905, which is greater than 0.05. It means this diet plan is not working for reducing the weight of 10 women. Is it clear? The last case study, I'm taking the chi-square test. Basically, it is the categorical data for the variables categorical. So in this chi-square test, the case study of chi-square test, I'm showing you. नहीं, इसमें केस स्टडी चलिए. सो केस देखिए इसके. Now you can write the results. The weight of participant did not significantly change over the 2 months of the diet. So because chi-square test value 0.20 and p-value 0.95. Next case study that is related to chi-square test. In chi-square test, both the data categorical. In this data set, you can see the 12, how many observations? 150 observations. So it's a training, the reward, food as a reward. The trainer wants to know whether food as a reward or affection as a reward working for the animals or not. So there is a cat, 150 cats, and out of the 150 cats, the trainer giving the food as a reward. Out of the 150, how many cats? I think 30 cats. He's giving a food as a reward to cats to the dance. And there are two options for the cat. Cat may dance or do not dance. Yes, when experimental trainer giving the food as a reward, cat dance. You can see. But some cats are not dancing. After taking the food as a reward, you can see. And another is affection. After affection, some cats are dancing and some are not dancing. You can see. So here we want to know whether for training the food as a reward is working or affection for animal only. Okay. So the go to analyze, descriptive statistics and cross tabs. Analyze, descriptive statistics and cross tabs. Type of training transfer into row, and did they dance transfer into columns. Then press this button, exact, nothing to do. The statistics, tick this option, chi-square, then continue, press this button, cells, observed frequency, and I'm taking expected frequencies also, and then row percentage. although there is no need of expected frequency, it directly analyze through observed frequency and then continue, and after continue, okay. Now you can see the results. The results, there are 150 cats and the trainer given food as a reward to 30 cats, 30 cats, and 120 cats affection as a reward, and out of the 30, 20 cats dance and 10 cats did not dance. If we convert this frequency into percentages, there is 66.7% dance and 33.3% did not dance after taking food as a reward. Then 120 cats, the affection as a reward, only 45 did dance and 75 did not dance. It means the affection, when you give affection as a reward to the cats, only 37.5% cats dance. While you giving food as a reward, then 66.7% cats dance. So through this data, whether this difference significant or not, this chi-square p value will tell us, and the p value is less than 0.05. It means there is a significant difference, and for animal or for cat, we can conclude that the food as a reward more important than the affects. So this is about the non-parametric test. Now you are most welcome to ask your questions. So you may unmute yourself and you can ask question. So do you have any question?
यस सर
Yes, yes. हाँ, प्रखर बोलो.
सर जब हम कोई पैरामेट्रिक टेस्ट लगा रहे हैं, फॉर एग्जांपल अगर हम इंडिपेंडेंट टी टेस्ट लगा रहे हैं और वहां पर हमारे जो ग्रुप्स हैं वो अनइक्वल हैं, उनका जो सैंपल साइज है दोनों ग्रुप्स में वो अलग अलग है, तो वो हमारे स्टैटिस्टिक्स को किस तरीके से अफेक्ट करेगा? और उसको मतलब हमें कुछ स्पेशल उसके लिए करना पड़ेगा या फिर वो हम नॉर्मल टेस्ट जैसे हम लगाते हैं वैसे ही लगा सकते हैं?
देखो प्रखर, हमें उसके लिए कुछ नहीं करना, बिकॉज हम अनइक्वल सैंपल साइज ले सकते हैं फॉर 2 ग्रुप्स, फॉर मोर देन 2 ग्रुप्स. क्यों? क्योंकि हम वहां पे क्या ले रहे हैं, मीन. वी आर कंपेयरिंग सैंपल मीन. सो अगर मान लीजिए एक एक्सपेरिमेंट ग्रुप में मेरे पास 15 पार्टिसिपेंट्स हैं, दूसरे में 25 हैं, कोई फर्क नहीं पड़ता क्योंकि हम मीन ले रहे हैं. ठीक है, मीन सैंपल साइज अगर इक्वल है तो ठीक है, कोई फर्क नहीं पड़ रहा, और अगर इक्वल नहीं है तब भी कोई फर्क नहीं पड़ रहा, क्योंकि हम मीन ले रहे हैं, मीन निकाल रहे हैं. ठीक है ना?
जी। और सर इसमें एक इंटेंशन टू ट्रीट एनालिसिस होता है सर। कई बार जो पब्लिकेशंस के जो रिव्यूअर्स होते हैं वो कई बार इस चीज़ को लेकर आते हैं कि अगर आपका सैंपल साइज डिफर हो गया या अगर आपके ड्रॉप आउट हो गए, जैसे हमने फॉर एग्जांपल हमने 60 का हमारा टोटल सैंपल साइज था, हमने उनको 2 ग्रुप्स में डिवाइड करा 30 ईच, और मेरे एक्सपेरिमेंटल ग्रुप से अगर 5 लोग ड्रॉप आउट हो गए ड्यूरिंग द इंटरवेंशन, और उसके बाद अगर मैं उसको रिजल्ट को दिखाता हूँ तो वो कई बार ये क्वेश्चन करते हैं कि आपका फिर जो रैंडमाइजेशन का जो प्रोसेस था पूरा वो फिर डिस्टॉर्ट हो गया, तो उसके लिए आप कुछ इंटेंशन टू ट्रीट एनालिसिस करके
हाँ, उसके लिए देखो ऐसा है, देखो एक जो है ना हमारे पास जी पावर होता है. मैं आपको शो कर देता हूँ. जी पावर एक सॉफ्टवेयर है, ये मेरे ख्याल में आप देख पा रहे होंगे, जी पावर. ठीक है ना? तो इसमें जैसे मान लीजिए ये टी टेस्ट है और मैं कोई टेस्ट लगाना चाह रहा हूं इसमें डिफरेंस बिटवीन टू इंडिपेंडेंट ठीक है ना, independent t test. I want to apply independent t test. Is it clear? And there is two tail. I do not know whether the result किस डायरेक्शन में जाएंगे, तो इसलिए मैंने यहाँ पे टू टेल लिख दिया. And the effect size 0.5. So there are three effect size: 0.20 small, 0.5 medium, and 0.80 larger. So generally we take 0.2 small effect. We want to detect a small effect, and then 5% significant level, and then you can the tick either 80% और the 80% भी कर सकते हैं इसको, और इसमें 95% या 90, and then you calculate, press this button, calculate. After calculate, you can see the sample size is 651 for each group. तो ये कई बार इसके ऊपर भी डिपेंड करता है. इफ यू इंक्रीज द इफेक्ट साइज और या पावर, अगर पावर मैं इसको रिड्यूस कर दूं 80%, जनरली 80% लेते हैं, तो इसमें सैंपल साइज फिर कम हो जाएगा. तो ये आ गया 394. तो एक तो ये तरीका है, इसमें से आप कर सकते हैं. दूसरा, कोहन ने एक टेबल दी है सैंपल साइज डिटर्मिनेशन की, तो उसके थ्रू भी आप जो है अपना जस्टिफिकेशन दे सकते हैं. तो चारा यही है इसका कि सैंपल साइज जो आप ले रहे हैं, जिस पर्टिकुलर टेक्निक को आप लगा रहे हैं, उससे थोड़ा सा ज्यादा लेके चलो. मान लीजिए अगर कोई इस तरीके की प्रॉब्लम भी आ जाती है या फिर दोबारा करना पड़ेगा, तो इससे अच्छा ये है कि अगर मिनिमम सैंपल साइज 60 है तो वी शुड टेक 70 और 80. ठीक है, तो ये साइंटिफिक मेथड है. और मल्टीपल रिग्रेशन अगर आप लगाना चाहते हैं तो उसके लिए अलग टेस्ट है. ठीक.
जी सर. सर इसमें जो पावर का कॉन्सेप्ट है, तो पावर का मतलब जो मेरा सैंपल साइज है उसके पास इतनी पावर है कि जो मैं इफेक्ट मतलब जो कोरिलेशन में बिठाना चाह रहा हूँ वो उस सैंपल साइज से निकल पाएगा कि नहीं सर, इसका
हाँ
मतलब
हाँ हाँ
होता है क्या?
हाँ, पावर का मतलब यही है कि जैसे मान लीजिए 80% पावर, तो 80% पावर का मतलब है कि आपके जो टेस्ट में उसको डिटेक्ट करने की जो आप स्मॉल इफेक्ट साइज भी डिटेक्ट करने की 80% क्षमता है कि वो उसको डिटेक्ट कर ले. 20% उसमें नहीं है. तो जितनी ज्यादा हम पावर लेंगे उसमें सैंपल साइज हमारा उतना बढ़ जाएगा. तो जनरली जो स्टैंडर्डाइज्ड है, ज्यादातर जो हम लोग लेते हैं वो 80% लेते हैं, और इफेक्ट साइज जो है 20%, या कुछ कुछ लोग 0.15 भी ले लेते हैं, और 5% सिग्निफिकेंट लेवल पर हम चेक करते हैं. ठीक है.
जी सर. और इसमें सर जो टेल है, अगर हम टेल को चेंज करेंगे, वन टेल करेंगे, तो उसमें भी
हाँ,
फिर
तब तो ज्यादा हो जाएगा, तब ज्यादा हो जाएगा सैंपल साइज. अभी देखो जैसे मैं ये शायद 1 टेल कर रहा हूँ. एक मिनट. देखिए इसमें ग्रुप में, सॉरी, अभी हमारे यहाँ पे कितना रहे, 310. ठीक है, और 2 टेल करने पे वो चेंज हो जाएगी वैल्यू 3. देखिए 1 टेल करने से कम हो रही है, मतलब सैंपल साइज कम हो रहा है. 1 टेल मीन्स यू आर श्योर कि आप किस डायरेक्शन में, आपको पता है आउटकम कि इसका, कि जैसे डाइट प्लान आप दे रहे हैं या योगा आप कराने से आप कह रहे हैं कि वेट लॉस होगा, तो आपको मालूम है कि वेट लॉस होना ही है. जब आप श्योर हैं आउटकम आपका उस डायरेक्शन में जाएगा, तब आप जो है 1 टेल लेते हैं. ठीक है ना. जिसमें हमें पता नहीं है आउटकम हमारा किस डायरेक्शन में जाएगा, तब हम 2 टेल लेकर करते हैं. तो बहुत सारी सोशल साइंस की जो रिसर्चेज हैं उसमें 2 टेल लेकर चलते हैं कि जो परसेप्शन है लोगों का टुवर्ड्स पर्टिकुलर फिनोमिना को लेके, वो पॉजिटिवली इसको परसीव कर रहे हैं या नेगेटिवली, हमें नहीं पता. जब नहीं पता होता आउटकम, तब हम 2 टेल लेते हैं. ठीक है ना.
जी मतलब सर, जब हम हमारे पास एक नल हाइपोथेसिस भी है तो हम फिर टू टेल को लेकर चल रहे हैं?
देखो 1 सैंपल में भी हम जो है नल हाइपोथेसिस लेंगे. 1 सैंपल में भी हमें पता थोड़ी है कि वो होगा. हम तो कह रहे हैं कि वेट, योगा करने से वेट कम होगा, ये हम मान रहे हैं ना, इतना हमें पता है. अब नल हाइपोथेसिस हम कह रहे हैं कि देयर इज नो सिग्निफिकेंट इम्पैक्ट ऑफ योगा टू रिड्यूस दी वेट. कोई फर्क नहीं पड़ता. जैसे योगा करने से पहले वेट था वैसे ही बाद में रहेगा। ठीक, तो इसमें भी वन सैंपल टी टेस्ट में भी हम अपनी हाइपोथेसिस दोनों ही टेस्ट करते हैं, नल हाइपोथेसिस भी और अल्टरनेटिव।
जी मतलब सर कई बार हमारे जो गाइड होते हैं वो ये भी सजेस्ट करते हैं कि अगर हमारे पास कुछ प्रीवियस एविडेंस है सिमिलर स्टडी का और वहां पर कुछ पॉजिटिव इफेक्ट आया है तो फिर हम नल हाइपोथेसिस को अवॉइड करके ऑल्टरनेट हाइपोथेसिस पर ही चलते हैं।
नहीं नहीं, वो और लिखने का तरीका अलग है। जितने भी रिसर्च पेपर होते हैं उसमें कहीं भी नल और नल हाइपोथेसिस नहीं बनाते। जितने भी बड़े आप एबीडीसी जर्नल्स के पेपर देखेंगे या वहां पे सीधा अल्टरनेट हाइपोथेसिस को ही लेकर चलते हैं कि इसका सिग्निफिकेंट इम्पैक्ट आएगा। और अगर पी वैल्यू 0.05 है तो ठीक है कि सिग्निफिकेंट इम्पैक्ट आ गया, और अगर नहीं आई तो हम कहेंगे कि सिग्निफिकेंट नॉट सपोर्टेड या रिजेक्टेड ऐसे लिखते हैं। तो कभी भी किसी भी रिसर्च पेपर में दोनों हाइपोथेसिस नहीं लिखते हैं हम, नल हाइपोथेसिस और अल्टरनेट हाइपोथेसिस। हमेशा जो हम लिखते हैं, आजकल जो ट्रेंड है या पहले से ही जो अच्छे रिसर्च पेपर्स में, वो अल्टरनेट हाइपोथेसिस ही लिखते हैं।
जी ठीक है
ठीक है,
सर।
एनी क्वेश्चन? चलिए, थैंक यू वेरी मच।